Good morning, dear colleagues. Today is the second day. We're starting our plenary lecture with Professor Christos Xenakis from University of Piraeus, with the title of his lecture, Securing the AI Life Cycle, Trust by Design Approaches to Adversarial Threats. It's a very new direction in our specialist which we have, and it will be very interesting, his lecture. Thank you, Professor Xenakis.
Thank you, Nico. I think you can hear me well, if everything's okay. So it is an honor and pleasure for me to be here in this historic building to present a new approach that we follow in order to have, let's say, security by design in the new area, in the artificial intelligence technology, how we can secure this technology in order to have to apply what we say security by design. Okay, I think the motivation is not something that I have to insist. You need a lot of arguments, but AI now is everywhere, from smart cities, autonomous ships, 5G, 6G networks, medical devices. And in case we have a failure in artificial technology, in a system like that, then this can cause financial loss, service disruption, and even having dangerous lives of people. So another angle, another option is that we have seen a growing threat landscape because of AI, because of artificial intelligence, because the attackers now, they use AI tools in order to perform attacks. So we have, let's say, two problems. One problem is the artificial technology per se that has a lot of vulnerabilities, a new threat landscape, and the other, we have the traditional cyber attacks where are empowered, let's say, we can see a more intensive cyber attack because of use of AI in order to perform these attacks. Another parameter that we have to consider is that we have MLOps. MLOps is a machine learning operating system. How we integrate and continuously develop and integrate and test AI technology. And this is included within the existing system. This life cycle focus on operation, on performance, but has nothing to do with security, privacy, and trust. So we have to enhance this in order to have continuous integration and deployment of AI technology in the new emerging systems. Let's see the current approach. Okay, we have some security measures, we have some security approaches, but these approaches are either model specific, we have specific security approach for specific model, or attack specific. So what is the motivation? What is the difficult? What is the gap? We don't have a generalized approach in order to secure the AI system, the new emerging system, that this approach can scale to many systems and many attacks. So we need a platform agnostic adversarial AI defense framework. We need a framework with solution and procedure how we can secure the modern AI systems. Can we go to the next slide? Because I think, again, So this is actually a work that we currently do in a European funding project. The name is CPAID, and what we propose a cloud-based platform agnostic AI defense framework. And this framework includes generative AI, adversarial AI. So we can, let's say, generate adversarial AI attacks in order to have a knowledge about the new threats. We have AI-assisted IPS, IDS system, so we can We have an advanced IDS that is capable to detect attacks that empower from AI technology and also attacks that targets AI technology. We have a new risk management approach, because we have traditional risk assessment and risk management procedures that needs to enhance, to adapt to the new framework that is risk management for AI system. Data fabric. Data is one of the most important feature, one of the most important parameters in the AI technology. So we have to secure data, and how we can do this. A meta CM, a CM that is that operates in a meta level, in a upper level that can control and consume information from all the systems. And of course, we have an adversarial AI cyber range platform where we are capable to experiment and learn about the new type of attacks. And of course, as I said, we have this ML privacy SecOps, where we include security, privacy, and trust by design in the new integration procedure. So the new methodology that we propose, and I'm going to analyze in the next slides, is how we can mitigate poisoning and evasion attack, how to include security, trust, and privacy by design, how to evaluate the robustness of the machine learning and deep learning models, how we can perform continuous validation and resilience scoring. We need the new framework, the new approach to be compliant with EU AI Act and also the NIST AI Research Management Framework. And in order to, let's say, prove the added value of this approach, we validate this in a cloud and network technology. So let's see our approach, what we proposed. As I said previously, we have a new approach in order to perform continuous development, integration, and testing of AI models. We have AI-assisted adversarial intrusion detection and prevention system. So we enhance the existing IDS technology. We have adversarial AI cyber range. We experiment with new technology in order to create a new database to be used in the whole procedure. We have generative adversarial AI because we try to experiment and to generate as much as possible AI attacks. We have a risk management framework for AI system, a meta CM, a CM that operates at a meta level and can monitor all the procedure, and of course, as I said, CPA data fabric, a procedure and approach in order to handle and secure the data. Now, if we see the current detection approach are either attack or model specific. Actually, we focus on three types of attack: poisoning attack, where during the training period, the training phase of a model, someone can, let's say, compromise the data in order to corrupt the model behavior, in order to, let's say, train the model in a wrong way. Evasion attacks, where again at the testing phase, someone can slightly modify the data in order to force misclassification. Again, we have the model that takes wrong decision. Another type of attack is inference and extraction. Inference has to do when someone has to steal data, because another type of attack is when we have a model trained by some sort of data, some type of data, then an attacker can take the data that the model has been trained by simply put questions or have interaction with the model. So we need the model to respect the privacy of the data that has been trained on. And last but not least is extraction, when someone needs to replicate the model, has the model at his operation, and then try to bypass the detection or bypass the model classification, or steal the behavior of its model. So all these three, let's say, type of attack, we try to handle this in a generalized and way and adaptable way in each case. If we compare our approach with related work and the limitation that we have the related work, we have, let's say, 4 categories. In the category of generative AI for attack simulation, in this category, the existing work that we have is limited, mostly for data augmentation. We use generative AI to augment the data, to, let's say, to generate synthetic data, but not to simulate realistic attack. So with our approach, with our model, we try to use generative adversarial AI for generating realistic adversarial attack across all the 3-4 categories of attack that we mentioned previously. MLOps, as I said, is the way that we develop, test, integrate, and operate the procedure machine learning algorithms. The existing procedure focus on performance and interoperability. We include security, privacy, and trust in this life cycle. Regarding the detection method, currently we have attack or model-dependent detection methods. We try to adapt the detection method in order to have a more generalized model, and this can be achieved by AI-assisted intrusion detection and prevention system, MetaCM, a new layer of CM, and of course from continuous learning. And last but not least, regarding the context awareness and risk assessment, this is an unexplored area. We don't have specific solution about risk assessment and risk management of AI system. So we enhance the existing state-of-the-art tools in order to handle with this objective. And of course, innovation is the data fabric that we try to secure the data. The data, which is one of the most important features, let's say, in the AI technology. This is the architecture of our solution. I'm not going to analyze this scheme, but let's try to see step by step how we deal with our objective. In the MLOps, as I said, we have these features, these security measures that I'm going to analyze them in order to integrate security and privacy and trust in the management of AI systems. First of all, we secure the data. We apply all the security solutions from cryptography, from access control, from data governance in order to secure data, features, model, code, and the deployment. And we try by establishing, by using traditional security solutions to have end-to-end solution from all these, for all these features. We strengthen robustness via adversarial training. We train against adversarial training all the models, defensive distillation, and feature reduction. In this way, and some other techniques, we try to strengthen the robustness of the model. So we try to eliminate the vulnerabilities of our model. By generating an AI bill of materials, we detect and eliminate vulnerabilities of third parties. Another important, of course, in traditional security system, but also in AI is the vulnerabilities from third parties. Another option is to preventing data poisoning, because it is important to have accurate data when we use an AI system. So we propose and we have implemented validating and sanitizing procedures in order to secure the data either in the training phase or in the operation phase. We adopt the environment and the operational shift through context-aware monitoring. We monitor the context-aware, the framework where each system is deployed. And of course, we have continuous lifelong learning of everything. So we have this reinforcement learning. Everything is reevaluated, and the next step, it becomes more secure. In order to have the knowledge about the new type of attacks, as I said previously, we use generative adversarial AI. By this mechanism, we generate realistic adversarial attack. We use generative adversarial networks, LLM, and digital twins in order to generate various types of attacks. And in order to do so, we use an adversarial taxonomy. This is a work that have been done within this project. We have CPA data fabric that I'm going to explain later on, the next slide. And based on our cyber range platform, we have attacker knowledge. We experiment on attacker knowledge and we see how the attacker performs the attack in order to use this, in order to generate new type of attack. And we validate through a digital twin framework in order to see if the attack are realistic and if the security measure or the security procedure that we propose can be achieved and have the results that we want. Another solution is AI-assisted intrusion detection and prevention system. In this system, we use assembly learning and deep neural network, these two techniques, in order to enhance the capacity of real-time anomaly detection. We have lifelong learning with semi-supervised and reinforcement learning. We have federated and transfer learning approach for cross-domain adaptability, and we block adversarial attack at real time. Regarding the MetaCM, we categorized incidents using semi-supervised learning, and we include also explainability. We try, when the models, the intrusion detection model detects something, we try to provide the proper explanation by using explainable AI to see what has been detected. We aggregate alert from all the features, all the characteristics, all the models, all the modules of the system. We detect anomalies with clustering and anomaly detection. We automate response, either with ticketing or escalation system, and we process everything in real time in order to have rapid detection and informed threat mitigation. Now, another innovative part is risk management. Here we follow a new advanced approach. We simulate attacks, we detect vulnerabilities, and we also generate AI-driven phishing scenario, because another important feature that we consider is the behavior of the users. So we evaluate and consider the behavior of the system, but we evaluate and consider also the behavior of the user. So we manage risk, we mitigate risk, and ensure compliance with the risk management frameworks, as I said previously. Now, another important procedure is data fabric. As we know, data is one of the most important parameters in the AI technology. So what we try to integrate diverse various data sources using metadata-driven architecture and knowledge graph. So we try to homogenize and integrate, and we provide specific procedure, data and homogenized data from various data sources. So we can integrate in order all this data to be able to be used. So we transform the data as a product, because data, we have to consider data as products. So we transform the data as products, ensuring availability, traceability, security for AI workflows. So we protect also data. We sanitize data and we test the data. In order to secure the data, we have access control mechanisms. So we employ various access control mechanisms in order to ensure integrity and confidentiality. And of course, we support AI models with standardized discover and trace data. So this is one of the most important modules, because feeds with data the training, the testing, and the detection phase of the AI approach. And another innovative feature is adversarial AI cyber range. Here we have hands-on training of the users, of the administrators. And why? We try to engage participants through capture the flag exercises, capture the flag challenge, both red teams and blue teams, in order to let them know how an attack happens and what are the proper reactions that the user should have. So we simulate AI-enhanced social engineering and IoT security scenarios. These are the two scenarios that we have selected, but the platform that we develop can accommodate, can be applied in any other case, in any other scenarios. And also we develop cross-disciplinary skills for adversarial AI detection, defense, and incident response. So the outcome of this cyber edge is trained professionals. So we need, there is a gap, there is a lack of trained professionals. So we train professionals, and we also have the ability to provide a cyber edge certification. If a professional has passed all the tests, has experiment with all the exercise, can take a cyber edge certification about this knowledge. Now, in conclusion, with our approach, see what's the outcome of CPAID? We provide a unified end-to-end AI defense framework that includes measures, procedures that targets both traditional and AI systems. Integrates detection with risk management, risk mitigation, training, and governance. The system will be tested in cross-domain applicability in smart cities, healthcare, IoT, maritime, and 5G networks. Embeds consider all the ethical AI principles and EU AI compliance with AI Act, and also the NIST, the US risk management framework for AI technology. It provides hands-on training and certification for professionals, and supports risk-based AI validation and certification. So all in all, what we try to see the new emerging AI system and try to develop a framework with procedure and measure how we can secure this in an agnostic way. We don't target to a specific technology, to a specific model, or to a specific use. I think this is my presentation. Thank you, and I'm happy to answer to any question.
Thank you very much, Professor Xenakis. Very nice, very useful, a very nice lecture. Please, do you have any questions from our... Huh? Please, any questions, please?
Yes, of course.
Please, Professor Hatchenko.
Thank you very much for your presentation and very systemized report about this very important problem. My question is the following. What about application any type of redundancy to detect and to provide dependability and all characteristics, more specific characteristics for AI system, similar trustworthiness, maybe responsibility, and so on? Because now a lot of work are targeted in area more deep learning, more specific methods to provide better functionality of neural networks. But what about classical dependability issue? Because it is a very important.
When you say classic dependability issue,
I mean, we can separate AI as a model, as a spirit, and the system in general. Hence, if you talk about classical dependability, we need to be sure that our system will be dependable. Hence, what about application? Maybe traditional methods for providing of dependability for such kind of system for AI components, because, for example, we can use different data sets to support functionality of your models and so on. Thank you. I understand that my question.
Yes, and this is MLOps. Actually, I went quite fast because it's a very big framework. But this has to do with this let's say feature, ML privacy SecOps. We have for traditional system, the current technology, we have DevOps. So the development, how we develop, test, integrate, and operate. MLOps is an extension of DevOps, but MLOps without security and privacy. So ML privacy SecOps is the next step of MLOps. So I think we treat in this way. Now we have DevOps. DevOps, okay, there are some solutions, some approaches that say secure DevOps. Now they are integrating security and privacy DevOps because, let's say, 5 years ago, we didn't consider cybersecurity in this DevOps ecosystem. So now we have DevOps with security and privacy. Of course, it's an open issue. We cannot say that we have finished with everything in DevOps, but again, there are some, let's say, some initiative, there are some procedure, and we also extend this. We don't came and say, okay, this is our approach. We use the DevOps approach with security and privacy flavor, and we extend this to what will come with machine learning and AI technology. Now, answer to the question, as I think is a chain. We have DevOps, we have security and privacy in DevOps. Of course, now we have MLOps because now the companies, especially in the financial sector, they integrate, they have machine learning, they have AI technology. So they use MLOps in order for continuous development integration of machine learning. And our approach is how to secure all this life cycle. So I think it is a continuous, let's say, effort that has started from DevOps, the microservice and all that stuff, and now continues with this the new developments. Another important issue that I have to admit is that when we start working in this project 2 years ago, ML privacy SecOps, it was something that came from a god. And now it is a reality because we see now banks or AI companies that work on AI, they try to incorporate some feature or to establish some procedure because they care about security and privacy of their models. So the things are growing and very, very fast.
Yes, we need to apply life cycle approach based on ideas and so on. And it's concerning the process and product. Yes. Thank you very much. And maybe second question, if possible.
We have plenary time, so please.
My question related, what about scenarios, AI-powered attacks against AI-powered protection? I mean, we have three senses. First one, AI as asset, AI as a means for protection, and AI as a means for powering of attacks. Could you comment this your result in point of these scenarios?
Actually, we don't have a clear result up to now because we are in a work in progress. Because this approach, this is our approach and our architecture that we have concluded a few months ago, and now we have started working in each area. But in order to try to deal with this, we have, let's say, two module or two approach. The first one is generative AI, generative adversarial AI. So we have done a taxonomy, we have done a deep, let's say, research on different options of how we can use AI in order to perform cyber attacks. And we have trained the models, and now we are experimenting to see a large set of different cyber attacks empowered by AI. And another is the cyber range, because we take all these scenarios, all these attacks, we create, let's say, some realistic scenarios, and then we have the professionals that they experiment, they try to solve the exercise or try to detect this attack. So by using this, and also by digital twins, because in some case, for example, for a maritime, we use a digital twin to see if an attack can occur in a autonomous ship or in a 5G network. And by experiment on all of this, we envision to have a data set, to create some data and say, okay, this is a set of possible adversarial AI attack in these categories for this model and for these use cases. And of course, this will be published, and after that, all the, let's say, the researchers and our colleagues in all over the world will experiment, will adopt and try to extend this. Because, okay, we cannot say that we are going to solve everything. It's a starting point. It's an initial point where we put a framework and try to generate some data, generate some results, and then to contribute to this research.
Thank you so much for your explanation.
We have question from our colleague. Yes. Yes.
Please ask your question. There was a person that had raised hand. Can you please ask your question?
Yes. Yes. Can you hear me?
Yes, loud and clear. Thank you.
Thank you so much, Professor Xenakis, for your insights. I really enjoyed your talk, and I have a question regarding of one module that you mentioned, in particular, AI-assisted intrusion prevention system. So when we talk about intrusion prevention, we assume some active actions from the system. Yes, and in case of AI assistance, we need to rely on decisions made by AI. So the question is how to ensure the necessary trust level to such actions, and how to evaluate or prove that AI assistance would really be beneficial for intrusion protection. Thank you.
Yes, you mentioned something very important. It's AI intrusion detection and prevention. So we try to detect, and as I said, with ticketing system and all that stuff, we try to let's say, trigger some security measures. So by using digital twins and also by the adversarial cyber range, we are in a process, let's say, to evaluate the proposed prevention method. Of course, there's an open issue. This is a framework we try to evaluate, and I think that by the end of the project, in 2 years from now, we will have some evaluation results. We can say that by this, let's say, semi-supervised or federated learning, we have this detection accuracy and also the accuracy of prevention method, because we are going to evaluate, okay, if the proposed measures will be 80%, 90%, or 60%. We are not sure about that. Now, what we have published, or we are in a position to publish and to work and publish, is all the taxonomy and, let's say, the behavior of some models regarding specific type of attacks. So we're at this level at the consortium. We study the attacks, the data, and the behavior, let's say, of the detection models or for the cyber attack based on specific situations, specific frameworks.
Thank you so much.
You are very right. It is an important issue to see the effectiveness of the detection, of course, and the prevention, because detection is one decision, but prevention is more accurate decision, because then the AI system decides for us. But I don't think that we'll be able or capable as person to propose security measure if we face AI-empowered cyber attacks. I think that at the first level, the system will respond, will defend us, and in specific cases, the person, the professional will handle specific situation. Because otherwise, you need an army of persons to defend the AI, and this is this is a critical issue.
Thank you so much. Thank you.
Thank you.
Is there any more questions, please? I have also one small question.
Yeah,
please, from the point of view of engineering, I'm interested. It's a system nowadays, what spec is Internet of Things, and moreover, Internet of Everything. Also, I saw that your system, the methodology are based on trust by design. So, as much more we have trust by the design systems, less performance that we have to our systems for applications. So, during all this methodology, which you can generate new attacks, and you have to learn about that and to make the calibration to the system. How is that possible? How is the performance? And how you make it on that?
You mean the performance in IoT devices?
Yes.
And all that stuff. Actually, we see IoT device as a module with no AI capabilities, so, because everything happens on the cloud. So we see IoT devices are as a source of data and as let's say components that they do some operations, they perform some functions. Currently, we do not focus on the AI or the interaction with AI with the system. That's why this is a cloud, this is a centralized approach, because we need processing power, we need unlimited, let's say, capabilities, and from the time being, we do not focus on IoT device. This is something that, of course, in the future we will see, but I don't think it is, okay, federation or distribution, yes, can happen, but I don't think that in the forthcoming, okay, 2 or 3 or 5 years, we will focus on IoT devices in, let's say, intelligence in this device, because, okay, the device can have some intelligence, but when we have to apply security and privacy by design in this, then the problem will be, it's a huge problem. It's a big problem right now, and we need the memory and the processing power. And by the memory, the processing power increase now in the energy. So I don't think we will
because
be
when we
capable.
speak about the trust by the design,
Yeah.
we keep in mind and devices and what is everything in the network.
You are right, but that's why we now focus on a cloud-based approach. So we centralize everything on cloud, and we focus on the central processing.
Thank you very much.
We can handle this by other solution. I'm thinking loud. I'm thinking loud now. By, let's say, trust management approach. So how we can, if we see that a device or some device has no trust, and we have done some work in trust management of IoT device, then we can isolate or can disconnect some device that do not perform properly. So this is the only way that we can deal for the next years, I think.
Very nice, very nice. Thank you very much.
Thank you
very much.
Thank you very much.
Который час?
10:27.
So we'll have a coffee break now, and we will start 10:45. Thank you very much.